right, so we're going to start with mean value theorem, which we just determined mean means average, right? So this says, suppose you are driving 50 miles an hour on a highway where the speed limit is 60, and you pass a parked police car. 4 minutes later, you pass a second parked police car traveling 50 miles an hour. The distance between the two police cars is 5 miles. The patrolman in the second police car pulls you over and gives you a speeding ticket for driving 75 miles per hour. Is the ticket justified? No. Why not? Because that's illegal in Texas. We don't know what state we're in. Why is it? Because you were speeding in between them, right? So let's look at this. So your speed, it is like miles per hour, right? So it's the change in the distance over the change in the time, right? So the distance, let's see, distance between the two police cars is 5 miles. So this is 5 miles over, what was it, 4 minutes? 4 minutes, okay? Well, we have to change that to miles per hour. So we're going to multiply, and we need minutes to cancel out. And we need that to be hours, right? So those will cancel. So 60 minutes in 1 hour. So when I take, what's 60 divided by 4? 15, so it'd be like 5 times 15, which would give me 75 miles per hour. So is that ticket justified? Yes, although it is illegal to do it that way in some states. I don't know if it's in Texas or not, but that's the way some tollways somewhere, that's what they would do. They would clock you and then clock you again and give you kind of one of those automatic tickets, but then people fought it or whatever because they don't understand math and they think it's not right and whatever. But clearly somewhere along, does this mean you were going 75 miles the entire time? No. Were you probably going faster than 75 miles per hour at some point? And also less, right? Okay, so what's happening here is this. If we have a little graph, okay, we can say this is our miles. So let's see, 25, 50, 75, something like that. And then whatever. We're not going to make this perfect. And this can be our minutes, I guess. Those are our 4 minutes. So 25, 50. So we're at 50 here, and then we're 50 here again, right? So, but we clearly sped up and then slowed back down. Well, the change in this right here, this average rate of change between these 2 points, right, and this right here would be the same, okay? Obviously, see how you have like a tangent line there? So at this point, we're going 75 miles per hour, and it equals that rate of change right there, okay? They're the same. So the average rate of change equals your instantaneous rate of change at some point. That's what the mean value theorem is saying. There is a time, we don't know exactly where it is, maybe, but there is a time where that's going to happen. Okay, so this is what this says. So if we have this point right here, so this point right here is A, what would the Y value be? If this is f of x, this would be f of A, and then this is B, and this would be f of B, right? So I'm going to connect those two. That right there is the secant line, and the slope of the secant line is my average rate of change. Does that make sense? Okay, so there is a time somewhere along the way where I would have a tangent line that has the same slope. That is the instantaneous rate of change at this point. So there's one time between A and B where my instantaneous rate of change equals my average rate of change. Does that make sense to you? And my actual rate of change is more and less than that along the way, but that's what your mean value theorem says. There is a time where my instantaneous rate of change equals my average rate of change. So that's what all this says, mean value theorem. If a function, and there's a couple of things that have to be true, has to be continuous on the closed interval and differentiable on the open interval. With this right here being your average rate of change equaling k, then there's at least one, because there could be more, number c in This where f prime of c equals k. So here's what all this means. This means that f prime of c, okay, which is your slope of the tangent, equals f of b minus f of a over b minus a, and that is your slope of the secant. So there's a time where the slope of the tangent equals the slope of the secant if it's continuous and differentiable. Another wording is important here. So your slope of your tangent is your instantaneous, oh, I think that's how you spell it. Instantaneous rate of change which we can abbreviate as IROC. Instantaneous, that's a long word. And then your slope of your secant, that is your average rate of change. That's where the mean comes from. And that can be AROC. So with the mean value theorem, f prime of c can equal the slope there. Slope of tangent equals slope of secant. Instantaneous rate of change equals average rate of change. That's where your mean value theorem is coming in. And I think I drew this with my sleeve, so I'll erase it so there's no confusion. Okay? How are we doing? We doing okay? Not that bad. All right, so now we have this function, f of x, on the interval from 1 to 5. How many values, so this question says how many values of x in the open interval from 1 to 5 satisfy the conclusion of the mean value theorem. So going from 1 to 5, well, I'll actually hit it. 1, 2, 3, 4, 5. So we're going from here to here. So I have this point and this point, right? So I'm going to connect those. This ordered pair is 1, -2. And this one is, what I do? Oh, I didn't count. I counted from that. Thank you. Dang it. Oh, what kind of, you have a lot of faith in me when I can't even count on a graph. All right, let me do that again. 1, 2, 3, 4, 5. Thank you. That's why I was actually counting up there too, so I wouldn't hit the wrong thing. So now that I have this right, and I'm going to connect it again. Sorry for those. Thank you for stopping me. 1, -2, and then this is at 5, 2. Okay. So what kind of line is that? Secant or tangent? Secant. Okay, so the conclusion of the mean value theorem says there is a tangent line on that interval that has the same slope as, at least one, that has the same slope as the secant line. How many would there be? If I put my pen here, and this is my tangent line, if it has the same slope, they have to be parallel, right? How many times is it going to be parallel? Just once on this one, right? So there'd be one point right here somewhere right about there, where they'd have the same slope. So the answer to this is 1. Okay. So we are going to show that the mean value theorem applies. And when we do this, we have to check the conditions. So don't jump into it before, just start doing things first. Make sure that our conditions are going to be met. So the first one is that it has to be, so f of x, this is f, right? Okay. F of x is continuous on 1 to 5. Is that function continuous from 1 to 5? Yes. Check. Then 2, f of x is differentiable on the open interval from 1 to 5. When you're looking at a graph, what makes it not differentiable? Sharp corner, which is also called a cusp. Okay, either one's fine. What? A jump, right? Not being continuous, right? If it's not continuous, it can't be differentiable, so a jump works. Asymptote, what kind? Vertical. Vertical asymptote, not being continuous. So we don't have any of that, right? This is a nice, pretty curve, totally differentiable, so we're good. Okay? So what I want to show is, I want to show that f prime of c, so it says find the value of c, right? F prime of c is going to be equal to f of 5 minus f of 1 over 5 minus 1. Okay, we want to show that that's true. We have f of x, we have it as a graph, and we have it here. So I need to first find the derivative, right? Well, I don't have to do it first, but we'll go ahead and find the derivative. F prime of x equals, well, what do you think that is? Should I rewrite that to make it a little bit easier? What's the derivative of 3? 0. So we really don't even care about that part. But this is negative 5 times x to the what? Negative 1. Okay. I suggest you do that because even if you're thinking about the exponent right, you might miss the multiplying by a negative part of that. So when I multiply negative 1 times negative 5, I get a positive 5, right? And then when I subtract 1 from this, what do I get? Negative 2, so that's over x squared. And it's positive. Okay. Everybody okay with that? All right. So then, let me ask you this. Is that if I gave you the interval from, instead of from 1 to 5, let's say we were going from negative 1 to 5. We don't even have the graph. We don't know what it looks like. Is this differentiable on the interval from negative 1 to 5? No, because if I substitute in 0, I'd get undefined, right? Make sense? Okay. That's not what we're asking. We're doing 1 to 5, so we're fine. All right, so I have that. Let's go ahead and finish this part out here. So f of 5, what's f of 5? 2 minus f of 1 is negative 2 over 4, right? So f prime of c. And then this is going to give me 4 over 4, which is 1. Okay, so that's this. We get 1 here on this side. This side, we have this, and we want to figure out what, we're going to substitute this in right here for this one, 5 over x squared. And we're going to say when the instantaneous rate of change, which is this, equals the average rate of change, that's what we're looking for, right? Instantaneous rate of change equals the average rate of change. You with me? That's why we substituted that in. So what do I do here to solve this? Multiply both sides and get 5 equals x squared. So x equals what? You don't see my head explode? What do I write first? Plus or minus the square root of 5. Now, that's what we get, which maybe both of them work. Do both of them work? Even if you don't know exactly what the square root of 5 is, will the square root of 5 fit between 1 and 5? Yeah. Okay. Will negative square root of 5 fit between 1 and 5? No. Okay. So that's our x there. So our c value is actually just the square root of 5. Okay. Everybody okay with that? That's the value where they're the same. What questions you got? This one asked me for the c value. Okay, so pay attention to the questions because this one just asked me how many times has it happened. This one asks me find the C value where it would actually happen. This one doesn't say to find the C value. This one says if the conditions are met, so if they're met, so we got to check that, determine the value of f prime of x that MBT guarantees. Okay? So we got to check our conditions. We can abbreviate a little bit here. So our first condition is that it's continuous on -1 to 1. We don't have a graph, but this is a polynomial. It's a cubic. Are they continuous? Yes, it's just a cubic. It's just a little curve, so totally continuous. Does a cubic have any discontinuities or vertical asymptotes or sharp turns? No. So it's differentiable on the open interval from -1 to 1. Check. Okay. And we want to show that f prime of C is equal to f of 1 minus f of -1 over 1 minus a -1. So in this case, I don't have a graph, so I need to actually find these. So f of 1, so 1 cubed is 1 minus 1 minus 2. -2, y'all agree with that? F of -1. So what's -1 cubed? -1. -1 squared is a +1, but that's a minus, so that's -1. Then -1 times -2 is a +2. So what does that give me? 0. So we're substituting in 1 and -1, which is fairly simple, right? Is it really easy to mess up signs here? Yes. So make sure, jot something down. Don't just stare at it and do it in your head, because that's where things go wrong sometimes. Okay, so then I know that f prime of C equals, well, f of 1 is -2 minus f of -1, which is 0, over what? 2. So then that gives me -2 over 2, which is -1. Okay. So our conditions were met. We're not looking for a C value. That's why I didn't take the derivative and put it back in there, because it didn't ask me to do that. It just said the value of f prime of x, which f prime of C is the same thing. We're just using C for x. Okay. What questions do you have? All right. Let's flip this over. Okay, we're going to determine whether or not the conditions of the mean value theorem are met. So we got to look at the conditions. And if they are met, find the value of C. So this time we're looking for the value of C. So we need to see if, number 1, it is continuous from 0 to 2 pi. And if it is differentiable from 0 to 2 pi. Okay? So let's sketch ourselves a little sine function from 0 to 2 pi. Okay, so we'll make that pi. Do you remember how to sketch this? Do you remember what it looks like? We're not having to do crazy. It goes like this, right? Okay, does sine start at 0 or start at 1? 0, because the sine of 0 is 0, right? And then the sine of pi is 0, and then the sine of 2 pi is 0. That's what sine looks like. That's something we have to know. Okay? Having that picture in your head can also help you with the values when you think about what they are and if they're positive or negative. Okay? So that's just there to kind of help us out with what's happening. Now, is this function continuous from 0 to 2 pi? Yes. Is it differentiable? Yes. Okay? So I'm good to go, right? So I want to show that f prime of C is equal to f of 2 pi minus f of 0 over 2 pi minus 0. Okay, so then we need to find f of 2 pi. That is the sine of 2 pi. And what is that? 0. Even if you're not sure and the graph makes more sense, look, at 2 pi we're at 0. It's 0. And then f of 0 is what? 0. Make sense? Okay, so you can use the graph to help you if that makes more sense than the units or whatever. So this is going to give me 0 minus 0 over 2 pi. So what is that? No, because this gives me 0 minus 0 over 2 pi. So it's just 0. Okay. I do need, though, f prime of x. So what's the derivative of sine? Cosine. Okay. You don't have to do chain rule or anything. It's just cosine. So cosine of x equals 0. And I need to solve that. Okay, on 0 to 2 pi. Now, the graph can help you, or maybe you know that. If the cosine of x equals 0, and you don't have to write this part, but that means that x is equal to the cosine inverse of 0. So at what values is cosine 0? Pi halves, and where else? 3 pi halves. Now, if this had said from 0 to 4 pi, then I'd have pi halves, 3 pi halves, 5 pi halves, and 7 pi halves. I'd have to keep going, right? Or if it said from 0 to pi, I'd only have pi halves. Does that make sense to you? You got to think about how many times you go, and this is your C value. Okay. What questions you got? Ask me a question. Okay, so this is what I did. I was doing this right-hand side, and I get 0, so I just brought this straight down. And then I just substituted this in. I probably should have used C, but I got that from over there. Okay, so like basically once I find this value, then I put in whatever the derivative is over there. Yeah, good question. What else you got? Anything? I don't think so, but that's a good question. I was kind of thinking that myself, and I was kind of thinking I wasn't sure what to say. So but that is a very good question, and I'm going to ask somebody that knows more about the testing part of that than I do. And I will clarify for tomorrow, because we're going to work on this some more tomorrow, but thank you for asking. Anything else? Okay, so let's look at number 3. All right, so I want to figure out if it's number 1, continuous from -1 to 1, and number 2, if it's differentiable from -1 to 1. Okay? Now, chances are pretty good you have no idea what this graph looks like, right? That's okay. So let's think about this. If it's something to the 2/3 power, you may not know whether or not it has a vertical asymptote, but it doesn't, okay? It's not going to have any discontinuities unless we have asymptotes or it's a piecewise function. There's no asymptotes in something like that, okay? And there's no reason for it to be undefined because everything I put in there is going to give me something out, okay? So it is continuous, yes. On this one, I'm not really sure how, well, it's a combination of a cube root function and a quadratic. So neither one of those do, so this shouldn't, but that is a very good, that's a hard thing to say. But I'm going to, without you knowing what the graph looks like. I feel like this isn't one that you would necessarily be given and be expected to know that. It just happens to be an example, but that's a very good question. So we're going to go with, I'm going to tell you, it's continuous. Then we're going to move on to differentiable. Now, again, you have no idea if it has a turn or anything in it, right? And so let's take the derivative. If I take the derivative of this and I find f prime of x, because we'd have to do that anyway, right? I'm going to multiply by 2/3, and then that would be times x to the what? -1/3, right? So that means that f prime of x is equal to 2 over 3 times the cube root of x. Now, chances are pretty good you have no idea what this graph looks like, right? Okay, but let me ask you this. I took the derivative. Is it differentiable from -1 to 1? If I substitute in every number between -1 and 1, am I going to get a value out? What happens when we substitute in 0? What do we get? Undefined. So it is not differentiable because when I substitute in that 0, I get a 0 in the denominator, it makes it undefined. Okay, does that make sense? Okay, so then we would say MBT does not apply because f of x is not differentiable on -1 to 1. So let's say you weren't sure. Oh. At x equals 0. I think we need to add that in there. Not differentiable at x equals 0, because it's differentiable on some of that, but it's not at x equals 0. So if you weren't sure about the continuous part, when you got to that part, then even if you couldn't speak to this, like we don't even have to talk about that now because it's not differentiable, you'd be like, I'm not sure about that, let me check this, and since it's not differentiable, it doesn't even matter if we had those asymptotes. Okay? So let me show you what the graph looks like. Which, again, you're not expected to know what the graph looks like on your own, but maybe it would be a graph that would be given to you, but it kind of looks like this, but better. Like a bird. It's symmetric, but my graph will not be symmetric no matter how hard I try, so pretend. So the reason it's not differentiable there is because it has that cusp there at 0. That's what's happening. Okay, that's why you're getting it undefined there. All right, what questions you got? Okay. So I want you to look at this one, and I want you to go ahead and write down your conditions, even though it's multiple choice, and then see if you can find your value of C. They want you bad. They're going to give you money. Hey, it's cold up there. Let me know if you're stuck on something. Who just said, what's the next step? Okay, so get your actual number. Did you get that? Oh, okay, I didn't say that. Okay. So now you're going to set that equal to, yeah, that, and then solve for it. Yes? Oh, wait. The mean value theorem. Oh, no, you don't have to solve for it because it's asking for this. You don't even need the derivative. What did I do? Oh, yes. Oh, Jesus Christ. Okay. 4x. Okay, now, are we looking for C? I did say when I told you to start this, to find the value of C. Are we actually looking for C? No. We could, though, and we'll talk about that. But once we get this, so f prime of C, which is what it's asking for, f of 4 is 36 minus 4 over 2. So that gives me 16. So luckily, even though I messed this up, it wouldn't have messed my answer up, right? But let's pretend that we were looking for C, okay? We're going to pretend and we're going to find it. We have room, right? A little bit of room there. Okay, so if we're going to find it, because I don't want y'all to have a weird brain fart on this kind of thing. If we were going to find it, so kind of separate question, right? Then we would substitute this part in right here. So 3x squared minus 4x would equal 16. Okay? Then what would I need to do? I need to solve for x. What would I have to do first? It's a quadratic. I got to set it equal to 0. 3x squared minus 4x minus 16 equals 0. That's what I was afraid of. You might do something weird when it's a quadratic. Okay? Then you would have to factor it. Okay? It's probably not factorable because that wasn't the question, but I just wanted you to think about what you would do. Okay? You with me on that? So don't forget everything you ever knew about quadratics. It's what I'm afraid of. Something that you need to factor that's easy is going to pop up, and you're going to do weird things like, I don't know what happens with weird quadratics. I see it all the time. Okay, we good with that? Okay. Any questions? Yes? When you're looking for C, because since it asked me for this value, I don't care what that actually is. I'm not substituting that in. I would do that, if I figured this out, that's going to give me the C value there. Okay, that makes sense? So I did it before I really read the question is what happened. Sometimes you do too much. All right, one more page. I know you're excited. We're not done. More notes. And we'll have more notes tomorrow to make sure that we can, because this is mean value theorem, which we're going to call MVT. What's the other thing we have with a VT in it? IVT. There's an EVT also, so you're not wrong. I just don't think we've talked about it yet. So there's also IVT and MVT, and we got to make sure that we can keep them straight. That's what we're going to look at tomorrow. Okay. All right. Here's a continuous function. This also goes on page 50. Define on this interval. Find the average rate of change of f on this interval. Okay. So it tells us to find that. And there's no point C. There is no point C. It's telling us there is no C, for which f prime of C is equal to that average rate of change. So let's find that first. So it's telling us to find the average rate of change. So we're going to find the average rate of change. Okay. That is going to be f of 3 minus f of negative 4 over 3 minus a negative 4. Y'all agree with that? Okay. What is f of 3? Can you read it? Negative 3, yeah. I don't know if you can read it. It's like a blob up here. And then f of negative 4, is that negative 1? Okay. Minus a negative 1 over what? 7. Okay, what's negative 3 minus a negative 1? Negative 2, so it's negative 2/7. Minus, yeah. Negative 1, right? Did we do that wrong? Oh, okay. Okay, just making sure. All right, so negative 2/7. So we got an A rock, right? And if we had the derivative, we could take the derivative, we could set it equal to each other. Maybe we find something, but it says right here, there is no point C for which f of prime of C is equal to the average rate of change. Explain why this statement does not contradict the mean value theorem. Because the mean value theorem says there is a point, but why doesn't it contradict it? Because it has a cusp, because it doesn't meet the conditions, right? So when we look at this, is this continuous on -4 to 3? Is it continuous? Yes. Is it differentiable? No. Not differentiable on -4 to 3. Okay? Which place is just here? Where else is it not differentiable? At -3, right? Okay, so we can say since f, well, just f, I guess, since f is not differentiable at x equals -3 or x equals 0, MVT does not apply. That's why it doesn't contradict it, because it doesn't meet the conditions. Yes, ma'am. I mean, it's fine, yeah. It's fine. I wrote it out the first time. It's because really it doesn't mean, there's not anything else that it would mean. Sometimes when we abbreviate things and they could mean different things, like sub, does that mean subtraction, substitution, so whatever. Do you have a question? Or are you just stretching? Okay. All right. Everybody good? What questions you got? Yes. The average, so yes, very good question. So the average rate of change from -4 to 3, that is your secant line. Because when you're finding average rate of change, you are actually calculating slope, and in order to do that, you have to have 2 points. Okay? Make sense? Very good question. Anything else? Okay. Now, let's look at this one. We won't finish this one, but I do want to start to talk about it. So the table below gives values of a particle's position, x of t, v of t, and a of t for selected values of t. The function a of t is continuous for all real numbers. Okay? So if this is continuous, then so is this, and so is this, and so forth. All right, so another way we could write this, so this is x of t, then v of t, that is x prime of t, right? Let me write it up here. Oh, you know, I've had this board for almost a year now, but I can't write, it's so thick. It just drives me crazy. This is the same thing as x prime of t. And then so how could I write this in terms of x? X double prime of t, right? So the acceleration is the rate of change of velocity. Velocity is the instantaneous rate of change of acceleration, right? But, and it says that a of t is continuous, and then it asks us, is there a time c such that a of c equals -2, okay? So a of c is the same thing as x double prime of t, right? In order to actually find the average rate of change that we have to, we use the x prime. Just like here, when we were finding the average rate of change, okay, we were using the f to find, and we were going to set it equal to f prime, right? So that was one of the things that y'all had trouble with on that test, right, using the wrong one. So if I want a of c, oops, a of c will equal to v of, what do we have, a 3 minus v of 2 over 3 minus 2. Because this is x double prime of t, and this is x prime of t. Okay, does that make sense? If you were looking for the average acceleration, you don't put acceleration in the average rate of change function when you're doing it. You with me on that? Okay, so let's just go ahead and figure out what this is, and then we'll go from there. So a of c is equal to, what's v of 3? 5 minus b of 2, negative 1 over 1. So that's going to give me 6. And then we'll stop there for today. Okay? We'll start back up there.